In its February 2015 publication, the National Institute of Standards and Technology asserted, "A new economy built on the massive growth of endpoints on the Internet will require precise and verifiable timing in ways that current systems do not support." NIST went on to elaborate, applications, computers, and communications systems have been developed with modules and layers that optimize data processing but degrade accurate timing. Dr. Thomas Fenning of Microsoft Corporation offered, virtualization technology, processor performance, and networking complexity outpace deliverable accuracy in legacy time synchronization solutions. He continued, worldwide large-scale data centers and cloud-based IT solutions create new challenges for operators, developers, and customers to meet business and regulatory requirements for workloads demanding system clock accuracy and precision across geographic locations. In his discussion about the blockchain transaction order problem, Dr. Mark Russinovich, the CTO of Azure at Microsoft Corporation, explained how this new technology takes a dependency on UTC-Accurate system clocks across the participating platforms. The transaction order problem challenge is agreeing on transaction order to prevent double spend. Ideal system uses a global timestamp to determine transaction order. Each timestamp includes the previous in its hash, forming a chain. But legacy time synchronization solutions are falling short. In their October 2015 publication, researchers at Boston University called out the risk of network attackers exploiting unauthenticated NTP traffic to alter the time on synchronizing client systems. Their research indicated that almost a third of the NTP time servers worldwide are lacking in both accuracy and trustworthiness. Ask Bjorn Hansen, the developer and maintainer of the crowdsourced NTP pool project, put it, "If business, organization, or human life depends on having correct time or can be harmed by it being wrong, you shouldn't just get it off the internet." Volunteer-based resources such as the NTP Pool project and its no longer curated predecessor at ntp.org do not indemnify you when you rely on them for your computer system clock accuracy. Meanwhile, the stakes are getting higher. Financial services firms operate under the rules set by regulatory authorities. In the US, these rules are set and enforced by the Securities and Exchange Commission. Its counterpart in the EU is the European Securities and Markets Authority. Both authorities have enacted new rules requiring better clock accuracy in computers being used for delivering financial services. In the US, the Financial Industry Regulatory Authority has been working with its member firms to meet the new clock accuracy requirements enacted by the Securities and Exchange Commission in July of 2016. Under the rule, the tolerance for computer clocks must be reduced from 1 second to 50 milliseconds by February 20, 2017. The European Securities and Markets Authority expects financial services firms to meet an even more stringent business clock accuracy requirement of 1 millisecond diverged from UTC. These requirements are applicable to computer systems that operate on premises and in cloud space. Financial services and information technology are 2 of 16 infrastructure sectors that the U.S. Department of Homeland Security has deemed vital to national security. These assets, systems, and networks, whether physical or virtual, are considered so essential to the United States that their incapacitation or destruction would have a debilitating effect on national security, economic stability, public health, and safety. These critical infrastructure components have become interdependent across vast regions, crossing jurisdictional and national boundaries and time zones. The need for accurate and precise position, navigation, and timing services has become more crucial. This increased dependency on timing services has left these sectors vulnerable to disruption. The Department of Homeland Security is inviting public and industry collaboration to develop assured timing technology for critical infrastructure that could easily integrate into existing systems. The goal is to provide secure and thorough timing inputs for critical systems, and reliably detect timing errors or manipulation. These contemporary challenges have not been resolved for organizations that made Windows a foundation of their IT investment. Microsoft guidance continues to warn users that the Windows Time Service cannot reliably maintain sync time to the range of 1 to 2 seconds. Such tolerances are outside the design specification. This stance renders all third-party solutions currently relying on the Windows Time Service framework suspect.